Welcome to IOT 310-R1, bringing intelligence to the edge for connected home use cases. My name is Dan Knoll, Product Manager at Amazon Web Services.
And I'm Ramin Firouzi, R&D Engineer with the R&D Innovation Team.
I'm going to be the straight man. He's the brains. Let's get that clear from the start.
He's kind.
I hope you guys are all enjoying the show. It's only Tuesday. We got a few more days to go. I wanted to mention some related breakouts that we think may interest you based upon you attending this session today. They're listed here, all having to do in some way with intelligence in the home, some of them interfacing with Alexa, some of them more general, like the last session there is focusing on machine learning with Greengrass. We're going to touch on some of these topics today, but you'll get a lot more depth in those sessions, so look for those, and hopefully you can register for them or wait for them. Also, we have a nice kind of open space in not only here in Hall C in this room for IoT, but in the ARIA, we have the AI, ML, IoT, and Robotics Networking Lounge. A lot of interesting stuff there, so if you haven't been to the ARIA, take the shuttle over there, find the Pinion Foyer was down at the first level. There's a nice setup there. Today's obviously the end of Tuesday, but it'll be open all day tomorrow, most of the day on Thursday, and the Connected Home demo at stand 225 in the ARIA also, same time as above, is we think you'll find interesting, basically aligned with the same theme as we're going to talk about today. So here, the agenda for our talk. So let's dive into that. So we're going to look at the connected home. We're going to look at the kinds of problems, the use cases, and then we're going to talk about the solution approaches and the solution elements that AWS has to offer to help you as developers and device manufacturers in attacking those problems and addressing those features and use cases. So we'll spend the first part of the presentation that I'll lead talking about that. And then we're going to pivot. We're going to kind of ask you to use your imagination in a bit to take a look into the future and imagine a world where we have augmented reality and some exciting new technology, which Ramin is going to do a deep dive into with some exciting, I don't want to give too much of it away. I'll make you wait the 15 or 20 minutes until he gets there, but he's going to talk about an exciting way to configure and to interface with devices that's unique and we think forward-looking. And we'll spend some time with that, do a nice demo. Hopefully his code will work live, and we'll summarize at the end. So the tagline of our IoT business applies, I think, really well to today's talk about intelligence in the connected home. And that's, as you may have all heard, if you knew the state of everything and could reason on top of that data, what problems would you solve? Let's look at the connected home market and think of it in terms of that quote. So I guess the first question we can ask is this a good market for local intelligence for us to do a deep dive about today? We think that it is, based upon the data that you see here. According to IDC, 832.7, so 833 million smart home devices have been shipped worldwide as of the end of 2019. So we've got a few more weeks to go to reach that number. 27% growth from the previous year. We look on the right, we're estimating a continued growth rate of almost 20%, 18.9, reaching a total of 1.56 billion devices shipped by the end of 2023. So the developer market for smart home is seeing a similar trend. A Vision Mobile's IoT report, smart home category, shows that this market, the smart home, is making up approximately 25% of the total of over 4 million IoT developers. So a pretty exciting space. So IoT solutions are already deployed in the connected home today. Here's a few of them kind of surrounding the home that you see in front of you. Let's do a little bit of a deep dive and examine what they do and how they use local and connected intelligence. On the far left, we have the CradleWise baby cradle. This is a signature AWS design win. We've done some references about it. And babies go in this, as you might imagine, and their sounds and sleep patterns are monitored. Music can be played, and we understand what correlates. The system can be made to understand what type of stimulus is comforting this child to sleep better, to be quieter, etc. So that's an interesting example of connected intelligence. On the far right, on the other side, let's flip the script to a completely different type of device. This is a flatbread maker, the Rotomatic Smart Bread Maker, which is using intelligence, using remote monitoring, It's downloading new recipes and new techniques, improving itself over time. It's got the ability, in any case, to measure parameters with respect to cooking flatbread, whether that's temperature, whether that's pressure, whether that's humidity, and be able to correlate that with the user preferences and things like that. So an interesting use of local intelligence to do something in the home. And let's show to ourselves that the home is not only the inside, we want to have a beautiful outside. The smart sprinkler system from Riccio that we see in the lower right understands the weather patterns that you're experiencing where this is installed. It has up to, I think it's 16 different zones that it controls that can have different soil characteristics, different plant characteristics. That's obviously configurable. We want to be able to obviously understand the preference patterns of the user. We want to understand their preferred times to do irrigation, and then account for those different zones and their needs, account for weather patterns, and that's another system that's connected to IoT and can be updated over time when new features added. Also on the bottom, we have the PetSafe smart pet feeder. I'm sure many of you, pets are very important in your lives, but in our busy patterns, we're not able to spend all the time that we need caring for them. We need help with that. And this is one of the devices that helps us with that, understanding, again, the levels that are preset, the patterns that the pet experiences or exhibits in consuming that food. So I think that's an example of a smart device requiring local intelligence. As we look at this broad space, intelligence in the connected home, we can start to basically understand patterns and certain types of use cases that seem to cluster. And one of those is home security. Home security, we can see we have a variety of sensors. Certainly we have video sensors, motion sensors, potentially other sensors like fire, carbon monoxide, water. And what we want our home security system to do is aggregate those inputs, do some correlation, learn what's normal for the pattern of the home in question, and take appropriate action and improve over time. So I think that home security is a really exciting example of intelligent home and the use cases around that. Smart appliances, we started to talk about. Of course, we have lots of appliances in our home. We have appliances that cook, appliances that clean. We have, of course, our entertainment systems, which we think of as appliances as well. In any case, it's this kind of triad of sense, learn, act. And there's lots of patterns. There's interactions between devices. There's updates over the cloud. Certainly we have Alexa-like ecosystems where we're learning and adding skills and gadgets and all that type of thing. So smart appliance is another exciting area for intelligence in the home. Health monitoring, we took a brief look at that with the CradleWise system. But of course, there's many examples of health monitoring that I think are going to be interesting in the home. Potentially monitoring the elderly, monitoring people that are recuperating at home through whatever they're going through. And again, we're going to be sensing, typically through cameras and potentially other sensors. We're going to be learning what's normal and what's expected, understanding what kind of events that we observe and what needs to be correlated with emergency type actions versus more routine actions. So I think health monitoring is a very exciting area in the intelligent connected home. And this smart home includes other systems like lighting, like heating, like cooling, and all the systems in the exterior of the home, similar patterns of learning, sensing, learning, and acting. And I hope all of you are aware or familiar with the AWS IoT solution elements around the Internet of Things that we are targeting for the connected home. So foundationally, we have Amazon FreeRTOS, the product that I manage. For microcontrollers, low-cost devices, we help low-cost devices connect securely to AWS IoT, can be managed, can be monitored, can obviously communicate data, and they can do that either directly to IoT Core or they can go through a local Greengrass core. AWS Greengrass, which is for Linux-based devices and gateways and other devices in the home, can aggregate inputs from multiple Greengrass-aware devices, can take local action. We'll dive into this a little bit more later. Can run lambdas, run machine learning, run inference, a very sophisticated environment in Greengrass. An IoT core acts, of course, as our message broker and the gateway to the other IoT services, where we have rules and triggers and events and things like shadows and jobs, and that can feed upstream to IoT device management and, of course, other AWS services upstream. So let's look at AWS IoT Greengrass, which extends the IoT paradigm to the edge. As you can see, a lot of bullets here, so a rich environment with lots of capability. We start with local messages and triggers, to local actions, data and state sync, security, and on. But basically, Greengrass can embed local Lambda compute, local messaging, device shadows for device and state synchronization, as well as security of communications and connected devices. This is effectively a software runtime that can be embedded in devices and allows you to have Lambdas inside those devices. So you're bringing the cloud computing paradigm into the edge, and in this case, into the home. You have the flexibility in the compute, events, triggers, shadow-based actions, etc. And it can run successfully without being connected to the internet at large, which we'll talk about in a minute. Again, over-the-air updates available so that I can not only introduce new features over time, but do normal type of maintenance. A security vulnerability can address those issues as they emerge over time. This is a little more detail about Greengrass. Again, local resource access, which we talked about with Lambdas. Machine learning inference is available with AWS Greengrass. And on the right here, we have this kind of virtuous cycle where data is collected and sensed locally. It goes upstream to IoT core. I can take some actions there. I can move that upstream to analytics and other services, aggregation, enrichment, etc. Cycle down to even machine learning models, databases, all types of other upstream services that I can use. And of course, the whole goal is to feed back intelligence to the devices, to update them, to cause actions to occur locally, etc. And Amazon FreeRTOS, the product I manage, of course, powers IoT endpoints, which are smaller, less expensive, based on microcontrollers. So it extends the open source and open and very popular FreeRTOS kernel, adds local connectivity libraries, secure cloud connectivity, and supports the over-the-air update service and code signing, as we talked about. And although Greengrass, it's very easy to see that Greengrass can participate in local intelligence by taking actions with Lambdas locally, running machine learning inference, doing all kinds of things that represent our notion of intelligence. One wonders if low-powered MCUs, given all they have to do just to do what we've talked about here, have enough space to handle intelligence workloads. So let's revisit that. MCUs are reaching, in some cases, gigahertz speeds. Of course, microcontrollers span the entire range of both the clock speed and memory that our silicon partners market to different market segments. As much as gigahertz speeds are being reached today by microcontrollers, as ARM announced at ARM TechCon earlier this year. So machine learning frameworks are emerging and communities are developing to specifically target microcontroller class devices with machine learning frameworks like keyword spotting, wake word detection, TinyML, TensorFlow Lite, and others. So I think the conclusion is MCUs can and will increasingly handle complex workloads that represent the intelligence we're looking for. And what problems are solved uniquely by local intelligence, either on a microcontroller or Linux-based devices like we have with AWS IoT Greengrass? Well, sending data into the cloud requires that I pay for those services. So that with a device, I've already paid for that. I guess that's the thinking. If I've already paid for it, I might as well use that compute as efficiently as possible. Secondly, what if I have intermittent connectivity or connectivity drops out entirely? If we think about the connected home, many use cases need to continue unimpaired even when connectivity to the internet backbone is broken. So we can think of that, hey, the power's on, but I don't have external internet connectivity. I still need to turn on the lights. I still need access to my appliances. I certainly still need access to a lot of the systems that we've talked about. So that can be solved by local intelligence. And latency. It takes time. Now, with high internet speeds, maybe this is a minor point, but it certainly does take time to ship data to the cloud, to have cloud take some type of intelligent action to feedback a result that I can act on locally. I may not be able to tolerate the latency that represents, depending upon the use case. And one example that I think spans all three of these vectors is video. So if I have high-definition video that I'm collecting locally, like in a security system, there's other examples for that, and if I need to upload that high-definition video to the cloud, that's going to cost a lot of bandwidth, that's going to cost money, that won't survive if external internet connection is not available, and it may not meet the latency requirements I have to process that video locally. So that certainly biases towards thinking about how can I do some type of local intelligence to solve that problem. And Greengrass is a great candidate for that. So now we're going to take a vector, we're going to pivot, and we're going to imagine a living room of the future. You've gotten the background about the smart connected home today. Let's think about what could exist in the future. So even if you go downstairs at the ARIA and see our living room of the future, you see lots of different devices. And you can be sure that every one of those devices has a unique interface, maybe even a local smartphone app that help me interact with it, every one of which is different. Every device has its own workflow. There's a lack of uniform personalization, lack of consistent accessibility. I assert that we can do better. And with that, I'm going to turn it over to my colleague Ramin to dive deep.
Can you hear me? Right. My name is Ramin, and as I said, I'm an R&D engineer with the R&D innovation team. And one of the missions of our team, we're about 40 people spread across the US and South America, is to go to customers and find problems that are hard and sort of help them over the hump and get them to think a little bit forward. And so one of the things we keep encountering is the issue with you need a special app for a device, for a connected device. And if any of you folks own smart home devices, you know that you go get a device and you bring it in and you have to go install the app, and then that app has to be paired and get on going. Well, now you need 5 apps for 5 devices. You need 10, 15. So scaling these up becomes an issue after a while. You've got different devices, different apps. Alexa has helped that to a large extent because it's giving you a universal sort of a voice control interface. But there's a lot of stuff that you can't do through voice that is cumbersome. So everybody still has their app that they communicate. So we started thinking about what could be a solution to that. What could be a good way to get around the one app, one device sort of scaling issue. And this is, let me go back. And this is what we came up with, was the idea that you can have an interesting, different interface for all the devices in your home. And so if you can sort of visualize with us, if you had augmented reality is a cool tech that's out there now for you, mainly being used for games. But if you had a way to visualize and control IoT devices through a portal, basically, either goggles or you're holding up your phone, and you're seeing this invisible layer of data that's going around, then that single app, if it could visualize and control all of those devices, I think it would be pretty powerful because it allows you to basically do one very important thing, which is to get rid of all the buttons. All of our devices currently have knobs, buttons, sliders, if you think, handles that open. And these are all IoT devices, essentially. But they go to an MCU inside the device itself, right? And that user interface is there so that people, us, can adjust the laundry load, or we can adjust the microwave time, or we can adjust the TV channel, right? Or we can look at the state of things out there. How are our sprinkler systems doing? So we think that having a virtual interface to these devices is pretty powerful because it gives you a bunch of things. It lets you have a software-defined interface, which means now you can rev how your device behaves by software, with software updates. Very simple. It also allows you to essentially have headless devices. Your microwave oven really doesn't need those buttons and panels if you had a way to control it, either through voice or through an app, right? So the cost, the bill of material cost of designing and implementing and manufacturing all of those user interface elements could go away. Essentially, everything could become a headless device, right? So this is one way to visualize that data, we think. So the solution we came up with, we're calling it AR-IoT. Figure out how to pronounce it. We call it AR-IoT, but A-Riot could be it. It's basically an augmented reality interface for IoT devices. And what's different about it is that the idea there is instead of hard-coding the communication mechanism to the devices into the app, which is part of the problem. I've been doing connected devices for more than a decade, and every time there's a new device, you need to figure out the communication protocol. You need to figure out what the UI is going to look like, how to interact with it, all that other stuff. Well, if you can abstract that communication interface and really simplify it, you can do some really powerful things. Now, if you have a single phone, let's say, that's going around trying to show you the interface, it needs a way to discover that app, that device, in 3D space, right? It needs to know that the refrigerator is over here. And then it needs to put the interface there, right? So if I'm moving around and I go back to it, the interface will be there. So you have to have a way to discover what's around you. And there's a number of different ways to do that, and we'll show you one of them. But this is going to be an interesting problem going forward because you're going to need a way for these devices to be discoverable, so you can find out where they are in physical space. So let's look at the architecture that we're proposing. Let's say you have a mobile device, and it has this SDK, the AR-IoT SDK, baked into it. And it's running an app, and this app is the one that finds different things and connects and communicates with it. Each of these devices could be running Amazon FreeRTOS. Why? Because it's small, it fits, it's very efficient, and the processors that we have now, and I'll show you one of them, the cost of them are dropping so much, we're hitting the point where you can probably get pretty soon, for under $5, a 32-bit processor and wireless technology in one bundle. And there are some that are cheaper that are coming out, but scale. So if you have these devices that have connectivity, the app could discover them, and you need to provide a way for them to be discovered. And if you have Greengrass in the home, acting as essentially a gateway, that's another way. And one of the benefits you get is latency goes very, very low in connecting and communication. You can have registry of the devices, locally what you have. It actually improves your security a great deal. And as Dan said, if the connectivity drops to the internet, you can continue operating with the devices because you've got Greengrass there. So once the SDK discovers these devices, it would go to the cloud, right? And if there's a description of how to communicate with the devices out on the cloud, it could go and get that and cache it the first time, but maybe even better if it gets it fresh every time because you could be changing some things. And on the cloud, it's a simple matter of having an API, having a Lambda, talking to a database, which is the registry of each device type. So the refrigerator, you can talk to it like this. This is the description. And so you can go to this registry and find out dynamically at runtime, the first time you see this device, how do I talk to it, right? And then at that point, you can start the communication infrastructure. If the device is sending the data live to IoT Core, the app can go talk to IoT Core, connect the two together, and you're good to go, right? If it's Bluetooth, it can locally set up the communication infrastructure, the services and characteristics, and talk to them locally if it's a low-powered device and you need it and you have a BLE interface. So this is a very simple infrastructure, and you all could have this server running in your own development environments. If you're a manufacturer, you could create your own. But we think it's better if there's a central registry, because what happens is if there's one app, if it knows about all the devices that are manufactured, then you can just walk up and go, boop, now you're talking to it. So what we came up with, we looked at a bunch of different standards, and we really wanted to simplify things, and our plans are, going forward, are things that we felt like the existing communication description languages didn't quite capture. So we came up with this very simple system called CDDL, Connection Device Description Language. Excuse me. It's essentially a universal communication interface, and it's really simple, and I'll show it to you. The version that right now we've got has an iOS-based SDK. We're working on an Android version as well, but it's basically designed to take care of all of the workflow of things for you. If you're an app developer, you can embed it in your app. Or we're going to have a single app, as sort of a demonstration one, that embeds all this. So we could have a single app if we want, but slowly get there. It takes a while to develop these things. The language is YAML-based. If you've used CloudFormation, you're probably pretty familiar with it. It's object-based, object-oriented. And by that I mean, if you have a description language that describes all of the light switches out there, they all do pretty much the same thing, right? You push the button, it's either on or off, there's a state, and there's an event, right? But some of them might have a dimmer. So instead of creating a different CDDL file for one versus the other and repeating everything, you can have a CDDL that describes all light switches, just basic light switches functionality. And then now you can have your dimmer one based on the other one. It's only the differences between that first functionality. And eventually you should be able to compose multiple ones. If you have a complex device, you can say, I want it to have a slider behavior, and I want it to have a push button behavior, and I want it to have this kind of thing. And so you don't need to come up with a lot of stuff, because there's a base set of functionality that will already be there. Right now, like I said, we have support for Direct Network Connect to IoT, and indirect support we're working on. So let me show you what CDDL looks like. This is an example of a base specification for a push-button device. Oop, I think I skipped past one. Let me go back. There we go. So there's a section in it that covers metadata. This is basically the name of the device. It's who makes it. Importantly, what type it is. And that keyword there, you'll see later. But the most important part is that GUID. That GUID describes the class of devices. It's unique. And the reason it's important is because when you're looking for a device and scanning, if it broadcasts that GUID, now the app can tell, hey, this is this kind of device. And it can go in and get the CDDL, which then tells it, here's how you talk to this class of devices. And the rest of it is basically for discovery. You don't need to provide that, but search engines and things like that. So in this case, this is a push button. And it talks MQTT, which is what AWS IoT supports natively. So very simply, we say, here's the MQTT. The data that's coming from this push button is in the form of a JSON packet. Now that's slightly different than what we're all used to. We define a single attribute to have a single value going into MQTT, usually. So in this case, we want to universalize it. So the value is actually a JSON packet, and I'll show you an example, which basically says, here's this kind of device, and here's this kind of value, right? And so the JSON path that you see listed there is basically telling it, hey, if you want the value, if you want the state of the button, go look for the state key. It's really simple. So if you want to make your own push button, one of the things you need to do is you would create this small file, which is based on all classes of push buttons. and you give it the GUID for your specific kind of it. Now, in the MQTT section, those of you who are familiar with it, it has basically a key value, which is the topic. And so you need to know what that is to go in and connect the front end to the back end, to the device. And the last one didn't have it because it's the base class. This one does. So this one specifically, for example, this is how you can talk to it. And at that topic, we expect a little JSON packet every time the data changes, going both ways. So in this case, oops, I'm skipping too quickly. This is the topic. So let me give you a demo, and hopefully it'll work. So here, we have a little construct. It's a little turn knob. This is an ESP32, which some of you might be familiar with. This is made by Espressive. It's got a Tensilica core with both Bluetooth and Wi-Fi. And this has shielding on it. So this little section of it, this is a little dev kit. This runs FreeRTOS natively. And it has a lot of goodies for development like USB and things like that. But it has lots of I/O. This is the dev version. And this could be a production version. And this is as small as you can get, right? And this is the PCB. The actual one is in there. You're going to need to put a little bit of shielding around it, but you can operate this on a battery if you want, on a small battery this size. So things are getting small. This is a full 32-bit processor with Wi-Fi and Bluetooth with BLE. So think about it. Small. And cost-wise, right now, I'm not sure lately what the bulk price is, but it's definitely under $10. And I think pretty soon it's going to drop to $5 or below, which means that your BOM cost is basically some passive parts and one of these, and you're good to go. You can connection enable your device, your appliance, with relatively little BOM cost. So this thing is that with a little enclosure for shielding, and basically this knob. There's also a little QR code on it. Now, this is where identification comes in. If you recall, I told you, we need a way to be able to identify devices. There are a bunch of different ways to do it. One is visual. Machine learning and computer vision is now powerful enough, and they run on the phones and soon goggles. So you can try to discern what an item is from the shape of it. That's one way. Not foolproof. If you have two of them, you need to disambiguate between them. If you have two light switches. Video is another way. So coming, still not quite there yet. Moving things around, you can say match this video, and then machine learning, same issues. BLE, you can have BLE broadcast. These things, if it has BLE, could broadcast that GUID that I showed you. And if something comes near it, you can find where it is and, boom, place it. Now, the thing is that in augmented reality world, you need to sort of place the thing, the virtual stuff, in 3D space. So you have to have sort of a scanning technology that gives you X, Y, and Z space, so you can place the thing that is on top of it. Otherwise, it looks kind of weird. With some of these AR glasses that we played with, you can stick them on the wall, because they do wall and surface detection. That's as far as they've gotten. But with the phones, it's kind of advancing a little faster. They're revving them better. So in this case, in iOS, you can place things in 3D space. And this QR code, all it is a GUID. So let me demonstrate how this might work. And hopefully, give me a second. I'm going to power this up, let it connect to the internet, hopefully. We've had some issues with connectivity, so we...
Let me know when you're ready to switch the...
We brought our own, but where did it go?
Okay.
I'm hoping... Oh, here it is. So I brought our own network. fell down. So hopefully it'll connect. So, hang on, let me.
Did I do it too early?
A little, but it's okay. So let's get past this.
Yeah.
So this is, excuse me. So what you're looking at is an app, is an iOS app that does what the stuff that I told you about. So let me start by showing you all. Wave at yourself. Hello. So now I'm looking around and I find this device. And hopefully, if I discovered, maybe the light here is kind of weird, so let me try it one more time. So it puts up a little virtual screen, right? And this is a rotary knob. Now, this is live demo, so bear with me if it doesn't work. We'll try a different way. So if I move this, did it again. Here, let me try it one more time. Now you know it's real. All right, so this thing is connecting Wi-Fi through this to AWS IoT. And the code on it is basically following the description in the CDDL that I showed you. So let me give it a chance to come up again, and if the network doesn't work, that works. We'll give it 1 second. Let's try it one more time. So here we are, and these lights are wiggy up here where I am. So let's see if it worked. I picked it up. Let's see. Nope, our network is down. So I'll try it one more time, but let me show you. I'll show you a canned version of this so you can see what it looks like, and then I'll try a live one. So let me go back to here. So if I want to run it, do I just?
Yeah. You should be able to just click right in the middle.
Here, let's do that. And while you're looking at it, I'll see what's going on with this one.
So this is a video that we shot before, so this is not live, of showing the virtual interface come up and have the knob turn, register the values as you'd expect up and down.
The rule of live demos strikes.
Is that up?
I'll give it one more shot. And if it doesn't work, I'll move on. Give it one last chance. Okay, let's give it one more shot. Pick it up. Give it a chance. Oh, I put it up there. Okay, here, let me make sure it, sometimes with lights and stuff, it messes it up. So I'll do one last live test here. There we go. And last chance. Woo! There we go. It worked. So as you can see, this is an AR interface to a physical device. And I didn't have to use this knob, but for the sake of this illustration, it's an easier way to show you this. So this is basically, think of this as a virtual interface to physical world, essentially. And it works in real time. So let me go back to the presentation. Actually, no, I'm sorry. I'm going to go back to my computer. I have more goodies to show you.
Want to show the code? Yeah.
Yeah, I'm missing a whole bunch of good stuff to show you. So let me show you a few things about how all of this works. So the device, as I mentioned, has a GUID. The GUID is the identification of that class of device. And in this case, This is a rotary knob, right? And the device is programmed to basically transmit that GUID. And the reason for that is because if you have multiple devices and you're connected to the IoT system and you're broadcasting, right, you can have multiple devices sitting on the same topic, and this lets you disambiguate between them, which works really well. The value is what you put in the CDDL file. And the CDDL file looks like this. Let me extend it. So this is the CDDL file for this device. This is actually, this phone app picked up the GUID on this, and it went to the cloud, where we've set up an API, and all it did is said, give me the CDDL for this. And it got it, and the phone app parsed it, found out where things are, and put it together. And I'll walk through the app and to give you an idea how this would work. So, as I mentioned, it has this GUID, right? This is whatever you want it to be, as long as it doesn't conflict. This is the topic that it's going to, and here's the value. And this value is what we're getting in this packet, right? So once the device, the phone, I'll try to disambiguate too many devices. Once the phone discovers the device, in this case with the QR code, goes to the cloud, gets the CDDL, brings it back, and then it creates a badge. And so let me walk you through. Some of you are iOS developers. This is not super developer-y Swifty. You don't need to know. I'll explain how it works. So there's a class here we have called IOT Connector. And this basically encapsulates all of the connectivity with AWS IoT. This includes all of the security, all of the logins, the check-in, the IAMs. If you've played with IoT, you're familiar with it. It takes care of all of that for you. And what it does is you can ask it to go and connect, and then when the connection is made, it simplifies all that to a callback that says, hey, here's what I got. We also have this thing called a device scanner, and I'll show you in this case. So what we do is whenever the app comes up, it goes and connects to the connector and initializes all of the IoT stuff that needs to be done, hide all the gory details. In, in iOS world, you want to save the battery. So when you're starting the QR scanner, you can keep it running, but it doesn't do you any good. So they recommend that you turn things off and on when the app goes in the background. Whenever the scan comes back and finds something, it returns that GUID. Remember, I told you the GUID is what we're getting back. And then it creates what we call a badge. And the badges are what that display looks like, right? And there's a badge for a numeric value, a badge for a color value, different badges, different ways to control things. We provide a bunch of different types of badges, and we hope that soon we'll be able to make them even more configurable and easy to describe dynamically. But for now, we've got like 8 or 10 different kinds of badges that automatically in the CDDL get associated. So whenever the badge is ready, if we're connected, we go to the CDDL, we get the topic, and then we tell IoT to set up a subscription. And if you've used IoT, it's this publish-subscribe model, which means that I'm interested whenever that value changes, right? So we get a notification. This thing, I'm turning the knob, and in real time, this thing is sending the value, that little JSON, to the AWS IoT system, and the phone is subscribed to that topic, so it automatically gets a notification, and now it can do something with it. Well, in this case, here, I'll jump back a little. Whenever the IoT is set up, we create the scanner starts doing its scanny stuff, and then whenever the data is updated, this is called. And so none of this touches, this is the external surface of the app. This could be your app. There's no mention of CDDL. There's no mention of MQTT setups. There's no looking for things and scanning and setting up AR worlds and all that kind of stuff. It's all taken care of. All this does is it basically does that sequence that I told you about. Scan, look for something, go find out if I know about it in the registry, get it, find out how I talk to it, display something to the user, and then wire them together, and then stand back. See what happens. So the devices, in this case, our scanner, has a bunch of different ways to discover things. And like I said, QR code is nice and reliable. Maybe you don't want QR codes all over your appliances and home stuff, but there's different ways. There's even better, barcodes. iBeacon or Eddystone are beacon technologies, and you can use that. But you need to have a way to find out and place in XYZ space. So the new BLE, if you guys are BLE geeks, AOA, AOD, doesn't make sense to anybody else, but it basically does micro-positioning of where things are. So in the near future, soon, it's in the standard, in the BLE spec, we'll be able to, from our phones, to exactly find out where something is. So that's a good, cool new technology. It's coming. The chipset manufacturers are actively working to embed it into their system. And as soon as that's set up, from the phones, that's a really good way to pinpoint something. Today, it's kind of vague. It's like, so, and then like I said, you can do image lookups, but it's kind of clunky. Today, it's going to get better. And the way it works is you have to give the system various pictures of what it's looking for. And then if it matches it through the camera, it goes, aha, I found this. Here's where it is. And a lot of the AR games use that, if you notice. And also, you might have noticed, a lot of them have QR codes on the ground, and there's a reason. They're very reliable right now. And the other one is video, which is you have to give it a video feed, and it tries to best match all that. That's even a little harder to control, but it's very early days. This just came out this year, some of this stuff. So we use the QR code, what I just showed you. The IoT connector is basically the mechanism that talks to the server, to the AWS IoT system, and gives you that endpoints to talk to, sets up all the configuration stuff that you need. And this is the CDDL identification mechanism. It takes care of all of the, I've got a CDDL, I've got to go get it from me, parse it, process it, tell me how to connect to this thing, and off you go. And the badge is, today, this is the first version of this. It's shaped like this. And if you recall, it has two little, our UI design person designed it so that you could put a little badge of the type of thing it is. It's a light. And then they put in the brand of the thing. And legal told us, you can't show brands. So I took them all out. There's an empty red dot on the top of it. And the reason is because we were told not to show brands. But in a full production, you can say, this is the Bose versus the Sonos speaker. You can put their brand on top of it. The manufacturer can put that stuff on top of it. And at some point in the future, we think you should be able to also just create your own UI, right? And have a way to define that so that dynamically, again, when you discover this device and you go to the cloud, you not only get how to talk to the device, but also what to show. And we're getting there. We're slowly moving that way right now. So this is sort of a deep dive into the code and the mechanism of how these things talk to each other. So let me switch back and... Whoop.
Yeah, you can advance it. That's fine.
One more. There we go. So what I showed you, or tried to show you, finally it worked, yay, was how to scan and identify these devices. And QR code currently is the most reliable, and it allows me to get XYZ coordinates. So today, it's a good way. I think going in the future, there's got to be a better way to identify physical devices. And so all of our brain power should focus, or some of us, should focus on how to identify objects visually and where they are in an XYZ space, because I think that's going to be one of the keys to make this very user-friendly. We also showed you how to connect to the IoT endpoints, so you can go in, the description's in the CDDL, you know what to get, and then you connect. And this technology that I'm showing you can work with multiple devices, right? We have badges for different kinds of data, and it doesn't matter how many of these we have. As long as that GUID is unique and the CDDL is in the registry, you're good to go. So this SDK wraps together all of how to identify nearby devices, how to go and get the CDDL data, how to set up the communications infrastructure, right? You don't have to deal with any of that. Starts communicating with IoT service, sets up all of your subscriptions and everything for you. You don't need to do anything. And there's a default AR IoT app, which is this, that you can use to try to do development. And eventually, if there's enough CDDL compliant devices out there, we could have just one. But it'll be one that, talks to your device and does the things that you want it to do. But now, imagine, you don't have to develop a custom iOS and Android app anymore. Because you can use this. And you can do all kinds of other things with it as time goes on, because one device, one app could talk to multiple devices. We think augmented reality is a good option to visualize this data. Think of it as an invisible layer of data that's flowing through the home, and things are talking to the cloud, and things are talking to each other. And AR is a good way to visualize that, to let people see it. They hold up their phone. It's that. I want to turn the light down. Put the phone down, go back to reality. There's no knobs and blinking lights and interfaces or anything. You don't need any of that. One of the advantages that Greengrass provides, like I said, is low latency. So if the application requires very fast throughput, if your specific application. Now, in the case of what I showed you, or in the case of a light, maybe you don't need to be super fast. It's okay. But maybe if it's your stove and you want to turn it off really fast, you don't want to wait to go to the cloud and come back. And Greengrass is really good for that. It also creates this class of what I'm calling headless devices. And I think this is where the UI is all in software. And the communication is all defined dynamically. And so this could be used in home, but my team works a lot with industrial, with enterprises, and there's a lot of interest in using it in industrial applications, so it goes beyond the home. And to summarize, I thank you, and I'm going to let my partner finish.
Hope you guys enjoyed it. We wrapped up showing how
Thank you.
AWS has solution elements today, and we have some futuristic ideas about how solutions can emerge to help this class of problems around local intelligence in the home. We've seen a lot of interesting use cases. I think you can imagine even more interesting use cases. That living room of the future, boy, I can take kicking back to a whole new level. If I can just identify, control. Anyway, I can imagine all kinds of interesting use cases there. And we're looking forward to seeing not only what we're going to develop over time, but what you all will develop over time with this kind of technology. So with that, we have a few minutes left and time for questions. I'll put up the standard IoT training and certification slide, but if anybody has questions, please go to the mics, and we'll be happy to take your questions.
I'll just shout out.
Okay.
So is the iPhone app, is that a thing with CERT in this case?
Yes. So the question is the iPhone app with certs?
Yeah, is it an IoT thing like a device?
Oh, the app itself is not a thing, but it has the certs to talk to. It needs it. It's a client that talks to the IoT service. So in itself, the app itself currently isn't. It's an SDK client that talks to the AWS IoT service. Does that make sense?
So I didn't
The
hear you.
devices are typically things defined in the IoT service, because you can then do things like communicate with them and update them and do firmware updates and things like that. Phones are locked in. Apple allows you to do firmware updates only, or apps updates only. So it doesn't make much sense to make it be a thing itself. But it's a client. Yes.
So I didn't hear any mention of security, defending the house from malicious devices or defending the house from malicious phones participating in the network. What about authentic? I mean, starts with identity, but then you have to authenticate and authorize.
Yep. Nope. Great question. Authentication and security, big, really big. So one of the things that you're going to want to do today, it's hard to do, is to dynamically establish communication with a device, exchange credentials to make sure they're who they say they are, and do authorization. Those steps you still need to do. But that's a subject of our group doing more things. As I said, this is technology. We do really sort of cutting-edge new stuff to move the ball forward. And so that problem itself is one of those that today, right now, there's not a good, easy solution. So we're working on technology to do dynamic exchange of security information in a secure fashion with these kinds of devices. And it's getting easier because now they have more and more secure enclave chips. So you can do a lot of stuff in terms of key rotation and getting to make sure that they're talking to the right entity. But you have to have the phone able to dynamically communicate and attach to those. And today, it's hard. So one of the things we're working on and to embed into the SDK, so you don't have to deal with any of this, this is all going to get taken care of, is to do exactly that. So the other problem, extended problem of that, is what if I have multiple phones? My wife has one, I have one, and I need to be able to, both of us need to talk to the same device. Well, it means that we need to have the cert exchange, all the key exchanges between two different phones, maybe three. My son has one. So that problem is even harder, but we're working on a solution for that as well. So at the dev level, nothing changes, right? It's all, you have one that you put on the device, and you can, again, with a secure enclave, takes care of all that. It hopefully will become as seamless as possible. And then on the IoT side, the SDK, just totally invisible. It'll take care of it for you. So that you can now, the idea is going forward is multiple phones talking to multiple devices, and nobody else, the authorization mechanism, is going to be there so that nobody else can cut in. And since they're all going through the AWS IoT service, it's end-to-end encryption all over the place. Oh, yeah.
Yes?
I'm sorry, I can't hear you. Would you mind? Sorry.
The question is like your mobile is offline, let's say.
If the mobile is off?
Mobile is offline.
Yeah.
So is your devices, those devices are going to cross-communicate each other?
Cross connectivity?
Yeah.
I'm not understanding the.
No, I have two devices, two IoT devices.
Okay.
Can they communicate each other without?
With each other.
Yeah.
In the future, they could, if they could scan and connect. But a lot of the devices, especially the low-powered ones, it depends on whether they can be central or peripheral. If they're doing BLE, if you're doing through Wi-Fi, they're on the same network. They could talk to each other if you don't have it. But that's kind of outside the scope of what we set out to do. But because you have the communication description language on the cloud, sure, each device, if they can detect each other, they know that they're within reach of each other. That CDDL is basically the API to the device. It's a description. So they could use that to discover how to talk to each other. And then go and discuss things. Talk amongst yourselves.
Okay.
The reason we put it together was so that we could support one app, multiple devices. And so that's the current use case. But, like I said, don't have to do that. Description's there.
Yeah, because there may be a use case where we have cross triggers, right? Like one device detects something, turn on light, or
So one device control another one, maybe do things like that. Absolutely, absolutely. If the API is public, I mean it's on a cloud. The one device. So actually, one of the use cases that we think going forward, home gateways are going to become important. And part of the reason, and they could be running Greengrass, even better. So home gateways, the phone doesn't have Zigbee and Z-Wave and these other kinds of radios in it. So if you have that technology in your home, you got to go through something that talks to them and then talks to the phone, right? So a gateway would be necessary to talk to the local devices and then go to the cloud for whatever you want and then talk to your interface. So if you had a gateway that could do all the cross-connect and it could have cached versions of the CDDL, it could also orchestrate multiple ones of these devices. So you could say, you could go in and say, turn everything off, and it would know, the gateway would know that this, all that stuff. A lot of that information today actually already is in Alexa, if you have that. Yep. A lot of work has been done in that universe, and we're going to be tying into that universe to do whatever the local, unfortunately, there's not enough information, like I said, for XYZ coordinate, so.
We're out of time.
Okay.
We're out of time. Thank you guys very much for a great session.
Appreciate it. Thanks for coming.